Hey guys, welcome to the section 4143 test review worksheet video. Okay, so let's go ahead and get started. For each of the following, please do the following. Sounds funny. Identify each sequence as arithmetic or geometric, and then determine the common difference or common ratio for each sequence. Remember, common difference goes with arithmetic and common ratio goes with geometric. All right, so let's go ahead and get started on the first one. Looking at the first one, we've got 2, 5, 8, 11, 14, 17. So right away, what is your gut telling you about this problem? Hopefully, you're thinking that it's arithmetic. And what we're going to do is we're going to check to see if it's actually arithmetic. And how we check to see if it is arithmetic is we're going to do the second minus the first, and then we would do the third minus the second. All right, so let's go ahead and do that. So second minus the first, that would be 3. And then we have third minus the second, that would also be 3. And then we have fourth minus the third, and that would be 3. And you can see that there's a pattern here. Every single time we have 3. And what is this 3 known as? This 3 is known as the common difference because I did subtraction to get him. That's why they call it a common difference. And what does it mean? It means we have an arithmetic sequence. An arithmetic sequence means we're adding to get to the next term. And you can see we're increasing here, so that's why it's positive. So it says determine the common difference. Well, the common difference is going to be that 3. Okay, now the next one. 26, 12, negative 24, 48, negative 96. So it looks like there's a pattern here. It's kind of going positive, positive, negative, and then positive, and then negative. So right off the bat, it looks kind of funky. It doesn't even look like it's matching up correctly because it should have gone negative, negative, negative because that's what an arithmetic sequence would do. Geometric would be negative, positive, negative, positive, negative. So it definitely seems a little off. And when we go to do the subtraction, if we do 12 minus 26, I get negative 13. And if I do negative 24 minus 12, I get negative 36. So it's not arithmetic because we don't have a common difference. So it's not that one. And then what we would try is geometric. And how we try geometric is by dividing 12 over 26, which would reduce to 6 over 13. And then if I do that again for the next one, negative 24 over 12, well, this is definitely not negative 6 over 13 because the numerator is larger than the denominator, so that won't be 6 over 13. So it's neither geometric or arithmetic, or sorry, arithmetic. So we should write neither next to this one. All right, next. 1, 1/4, 1/16, 1/64, 1 256. So even though your numerator is staying 1 the whole entire time, look at that denominator. The denominator is getting big, and it's getting big very quickly. And so what we want to think here is possibly geometric. And so let's go ahead and go with our gut and see if geometric actually works out. And remember, to check geometric, we do the second term divided by the first term, and then the third term divided by the second term, and so on and so forth. So let's go ahead and do that. 1/4 divided by 1, and if we put that in our calculator, that would give us 1/4. And if I did 1/16 divided by 1/4, if I put that into my calculator, I would also get 1/4. And if I did 1 over 256 divided by 1 over 16, if I put that in the calculator, I would get 1/4. So you can see every time I got the exact same number. That is known as my common ratio, and that means I have a geometric sequence. Remember what I talked about, the ratio, if it is a fraction between 0 and 1, your sequence is getting smaller, and our sequence is definitely getting smaller. If we take one pizza and cut into 4 slices, this slice is going to be much bigger than taking a pizza and cutting it into 16 slices, so this would be smaller. and then 0.13, 0.38, 0.63, 0.88, 1.13. I'm definitely thinking this is going to be a arithmetic sequence because it's increasing slowly and it seems to have the exact same space in between. So I'm thinking arithmetic, and how I'm going to try that is 0.38 minus 0.13. And when I do that, I get 0.25. I'm going to try it again. 0.63 minus 0.38. And when I do that, I also get 0.25. So 0.88 minus 0.63. That's also 0.25. And last, 1.13 minus 0.88 would be 25 cents. All right, so looking at that, we could see that there's definitely a pattern here. And with that pattern, I see that I subtracted. So this is known as my common difference. That's why they use the word difference there. Common difference. And I know it's going to be arithmetic because I added to get to that next term. To go from 0.13 to 0.38, I added 25 cents, or I added 0.25. All right, I think that takes care of the first problem. All right, for each sequence, write an explicit formula. AN equals A1 plus D times N minus 1, or GN equals G1 times R raised to the N minus 1. Then determine the 15th term in the sequence. All right, so we've got two explicit formulas. This is for your arithmetic sequences, and this is for your geometric sequences. And then we have to figure out, first and foremost, what sequence do we have? So we've got 5, 10, 20, 40, 80, 160. So as you can see, like the sequence is getting big, and it's getting big very fast. So we should think it's geometric. So I'm going to write geometric over here, which means if it's geometric, then I need to use G sub n equals G sub 1, parentheses R raised to the n minus 1. And if I'm writing an explicit formula, the only thing I need to replace is the first term and the R. That is it. So here's my first term. That goes in the 5 spot. And the R is going to come from doing 10 divided by 5, 20 divided by 10, 40 divided by 20. And what do we see all of these equal to? All of that is equal to 2. That's our common ratio, and that's going to go in the R spot. And then that's going to be how you write an explicit formula. G sub n equals 5 parentheses 2 parentheses closed raised to the n minus 1. Now to find the 15th term, you're going to take and you're going to put 15 everywhere you see an n. So I have an n here and I have an n up there, which means I'm going to take it, I'm going to replace those with 15. So it's going to be G 15, sub 15, that means the 15th term in this geometric sequence, 5 parentheses 2 raised to 15 minus 1, and I can put all that into my calculator just like you see it. 5 parentheses 2 parentheses closed, hit that caret button, which takes you up to the numerator, 15 minus 1, and that should give us 81,920. Hopefully if you got that right, or if you put it in your calculator right, that's what you should get. And remember, we talked about the numbers being so big because we were taking 2 and raising it to basically the 14th power. So that's why your numbers are so large for this one. All right, now let's look at this sequence. We've got 1/2, 1, 3 halves, 2, 5 halves, 3, and then 7 halves. All right, so it definitely isn't geometric because it's increasing very slowly. And I don't know if you can see it or not, but it's really only increasing by 1/2. But how can you figure that out? In your calculators, do 1 minus 1/2, and that would give us 1/2. And then if we did 3 halves minus 1, if you put that right into your calculator, it would tell you 1/2. But just in case you don't have a calculator, you'd have to find a common denominator. This would need to be 2, and the top would need to be 2, and then 3 minus 2 is 1/2. And see how you get the same thing? That becomes our common difference. And when we're figuring out the explicit formula for the common difference, that's all we need. All we need to do is replace the D and replace the A sub 1 to write an explicit formula. So for letter B, my explicit formula would be A sub n equals my first term, which is 1/2, and then I got a plus sign, and then d, which again is 1/2, and then I'm timesing that by n minus 1. This is my explicit formula. The trick with explicit formula is everywhere you see an n, it needs to stay an n. And then for the second part of this problem, then determine the 15th term. That means I'm going to put 15 into both of these spots. So this would be a sub 15 equals 1/2 plus 1/2 parentheses 15 minus 1. And when I put that into my calculator, if I use Mrs. Greco's calculators, you can type that n over d button and it'll be just as easy. So you would do 1 over 2, press that. Well, first press the n over d button for this fraction, and then you do 1 over 2, and then plus, and then hit the n over d button again, 1 over 2. And remember, hit that arrow, the right arrow button, to go out from underneath the fraction, and then parentheses 15 minus 1, and when you press enter, you will actually get the answer of 15 over 2. If you got 7.5, it looks like they want them all in fractions, so you just need to hit that arrow button and change that to 15 over 2. All right, anything more? Nope. Write a numeric sequence to represent each given pattern or situation. A numeric sequence is just a string of numbers. That's all you need to think of right there. The school cafeteria begins the day with a supply of 1,000 chicken nuggets. Each student that passes through the lunch line is given 5 chicken nuggets. Write a numeric sequence to represent the total number of chicken nuggets remaining in the cafeteria supply after each of the first 6 students pass through the line. Include the number of chicken nuggets the cafeteria started with. So our very first number is 1,000. That's our first term, a sub 1. And I'm using a because I'm going to be adding a -5 each time because I'm giving away 5 chicken nuggets. So a sub 1 is 1,000, but a sub 2, which is the second term, is my first student to walk through. I start off with 1,000, and now my first student walks through, and I have 995 left because I've given away 5 nuggets. Basically what you're doing is you're adding -5 to 1,000. And now the next student is coming through. So this is my third term, but my second student, and I'm going to have 5 less again, so that's 990. And then I've got my fourth term, which is my third student, and that would be, 985. And then 980 would be my fourth student. And then 975 would be my fifth student. I think that was supposed to be a H. And then let me see if I can squeeze this in here. 970 would be my sixth student. So it says include, where does it say? Sorry, the question was write a numeric response, or sorry, numeric sequence to represent the total number of chicken nuggets remaining in the cafeteria supply after each of the first 6 students. So here's our 6 students. So we have 970 left after the 6th student walks through. All right, guys, let's go to the next one. Okay, determine the common difference for each arithmetic sequence. So here I'm actually telling you that they're all arithmetic sequences, which is nice. And then I might not do that on the test. I might just say determine if it has a common difference or a common ratio. So you need to be able to know how to find that. But in this case, I gave that to you. So you're knowing that you need to go through and you need to do the second term minus the first term, and then the third term minus the second term, just to make sure that they match up. So let's go ahead and do second minus first. So that's 13 minus 10.5, which would be 2.5. And then I've got 15.5 minus 13, which would be 2.5. And see how I get the same answer? I know my D for the first one is 2.5. Now for the second one, I have 2/3 minus 1/3, which happens to be 1/3. And then I've got 1 minus 2/3. And again, if you don't have my calculator, then you're going to need to change this 1 to 3/3. And then, because that's just a common denominator, right? I do 3 times 1 and 3 times 1, and that's how I get 3 over 3. And then if I do that, I get 1/3. And again, I get the same thing. So my common difference for this one is 1/3. And then going to letter number 6, I have -28, -13, 2, and 17. My sequence is increasing, so I should have a positive number. So -13 minus a -28, that gives me 15. And then I do 2 minus a -13, and that would also give me 15. So I got the same thing. So my common difference, I just wrote CD for that one, sorry, is equal to 15. All right, determine the common ratio for each geometric sequence. So here we're finding ratio. Remember, to find ratio, we do second divided by first, or third divided by second. And it's a lot easier if you press that N over D button, because if you press the N over D button, it'll actually keep it as a fraction. So let's go ahead and look at this one. We've got positive, negative, positive, negative. So I know my ratio is going to be negative. And I'm going to go ahead and figure out which one it is. So I've got -6 over 3. That reduces to -2. And then my third term over my second term, that would be -2. So I see both of those are the same, which is good. So my common ratio is -2. All right, the next one, 45, 15, 5, and then 5/3. You can see your sequence is getting smaller. It's decreasing. That does not mean my common ratio is negative. It means my common ratio is going to be a fraction. So I've got to figure out that fraction. So I do my second term divided by my first term, and if I use that N over D button in my calculator, that's going to give me 1/3. If I did 5 over 15, that would also give me 1/3. If in your calculator you did 15 divided by 45, then your calculator would come up 0.033333, and you would just need to know, press that arrow button, and that would then pop up 1/3 in your calculator. All right, so my common ratio here is 1/3. All right, determine the next 3 terms in the arithmetic sequence. So we've got -24, -14, -4, and then 6. So to determine the next 3 terms, I need to first find D, which is my common difference, and that would be -14 minus a -24. And -14 minus a -24 is 10. And just to double check, I'm going to try the next one, -4 minus a -14, and that's also 10. So I just wanted to check to make sure. Now I'm going to go through and I'm going to find my next terms, and that's how I add with arithmetic. So 6 plus 10 is 16, plus another 10 is 26, plus another 10 is 36. Oh, I thought there was another page. Oh, I thought there was another problem on that page. I guess not. All right, determine the next 3 terms in the geometric sequence. All right, so we've got 5, -10, 20, -40. We can tell that my ratio is going to be negative because of the sign switching. So I do -10 over 5, and that gave me -2. Just to double check, try the next one, 20 divided by -10, and that also gives me -2. So I know my R is -2, so I'm going to go and multiply that through. -40 times -2 gives me a +80, times a -2 would give me a -160, times another -2 would give me a +320. Determine whether each given sequence is geometric, arithmetic, or neither. For arithmetic and geometric sequences, write the next 3 terms. All right, looking at this one, I've got 1, -4, 9, -16. So the first thing I need to check is arithmetic. If I do -4 minus 1, that gives me -5. And then 9 minus a -4, that's 13. Those are not the same, so it is not arithmetic. That did not work out. To do geometric, I divide -4 over 1, and that gave me -4. 9 over -4 is not equal to -4. So those are not the same, so it's not geometric. So the answer here is neither. Very good. Go to the next one. All right, 5, negative 20, 80, negative 320. This one is, it looks like geometric because look how big the numbers are getting. They're getting big super fast. It went from 5 to 20 to 80 to 320. So let's check geometric first. Let's see that one. That's what our gut is telling us right now is geometric. So let's do negative 20 over 5. That's equal to negative 4. 80 over negative 20. That's equal to negative 4. Oop, we might have a winner here. Negative 320 over 80. That's equal to negative 4 too. So that's my common ratio. R is equal to negative 4. It's geometric, so I know I'm multiplying. So to find the next three terms, I'm going to use that recursive formula, which is the idea of just multiplying the previous term by the R. So negative 320 times a negative 4 gives me 720. Oh, nope, that's not it. Sorry, guys, that's not it. It's 1280. So 1280, and then times that by negative 4, and you get negative 5,120. And then one more time, times that by negative 4, and you get a big number, 20,480. So my next three terms would be 1280, negative 5120, and then 2480. All right, let's see if there's any more on the bottom. Yep, one more. 9.8, 5.6, 1.4, and then negative 2.8. So this definitely doesn't look geometric, so let's try arithmetic, and let's see how it goes with that. So we're going to do 5.6 minus 9.8, and that gives me negative 4.2. And then I'm going to do 1.4 minus 5.6, and that also gives me negative 4.2. And last but not least, let's check negative 2.8 minus 1.4, and that is also going to give me negative 4.2. See how my sequence is decreasing because my common difference is negative. So here's my common difference. It's equal to negative 4.2. So to do the next three terms, I take negative 2.8, and I'm going to add negative 4.2 to that, and that's going to give me negative 7. And then to find the next one, I would just add negative 7 plus negative 4.2, which is negative 11.2. And then for my last term, negative 11.2 plus another negative 4.2, and that's negative 15.4. So my last three terms would be negative 7, negative 11.2, and then negative 15.4. Okay, hopefully, yep, that's it for that page. Determine each unknown term in the given arithmetic sequence using the explicit formula. So here they want us actually using it, the explicit formula. Determine the 20th term, and these are arithmetic. So what you need for the explicit formula for an arithmetic is you need the first term plus the difference, and then times that by n minus 1. So the first term is the number sitting at the very beginning, that's 1. The difference is going to be the second term minus the first term. So I know a sub 1 is going to equal 1. D is going to equal 4 minus 1, which is 3. So I'm going to put 1 into this spot and 3 into that spot. And then what number goes into the n spot? That's the term we're looking for. We're looking for the 20th term, so that's the number that's going to go in there. So a sub 20. And remember, this just means the 20th term in the arithmetic sequence. That's all that notation means over there. It doesn't go in your calculator. A sub 20 equals 1 plus 3, parentheses, 20 minus 1. Now, all of that can go into Ms. Greco's calculators that are in the class. If you have one of those at home, you can type it in just like you see it right here, and it'll tell you the answer. If not, let's work order of operations. 1 plus 3, parentheses, 19. And then we've got 1 plus 3 times 19 is 57. 1 plus 57 is 58. So our answer to this one is 58. Determine the 30th term of the sequence below. And again, we were told it's arithmetic. And we can see that the sequence is going further and further into the negatives. So our difference should be a negative number. Let's just find out what it is. We've got negative 15 minus a negative 10. That leaves me with negative 5. So there's my difference. So when I'm writing out my expression, or my explicit formula, I need the first term, which goes into that spot, and my difference, which goes into that spot. And then the 30th term, 30 is what's going to go into my ends. So I have a sub 30 equals negative 10 plus d, which is negative 5, parentheses, n minus 1. And instead of n, I'm going to put 30 minus 1. And again, all of this can go into your calculator. Notice I wrapped the d with parentheses because he had a negative sign with them. It's really important that you remember that. So I'm going to do negative 10 plus a negative 5 times 29. So I would get negative 10 plus negative 5 times 29 is negative 145. And then negative 145 plus a negative 10 is negative 155. So this would be the 30th term of that arithmetic sequence. All right, determine each unknown term in the given geometric sequence using the explicit formula. Round the answer to the nearest hundredth when necessary. So we've got this one, 3, 6, 12. So what is my sequence going up by? They told us it was geometric, so we know we're going to have a ratio. So we've got to do second divided by first, and that would be 6 over 3, which is equal to 2. And just double check to make sure, 12 over 6, that's also equal to 2. So my explicit formula is g sub n equals g sub 1 parentheses r raised to the n minus 1. The first term goes into this spot. The r goes into the 2 goes into the r spot, and then the term I'm looking for is what's going to go into the n. So 10 is going to go into the n spot, into those two spots. So I would have g sub 10, because I'm looking for the 10th term in this geometric sequence, equals 3 parentheses 2, parentheses closed, raised to the 10 minus 1. And if you put all that into your calculator just like you see it, the 3 parentheses 2 and then parentheses closed and then raised to the 10 minus 1, you're going to get 1,536 as my answer. So if you don't have that calculator, then what you need to do, 2 to the 9th, you're going to need to do 3 times 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. You would have to do that all in your calculator, and that would get you 1,536. All right, determine the 15th term of the sequence 1, negative 2, 4. So we got to find that r first. Negative 2 divided by 1 is negative 2. 4 divided by negative 2 is negative 2. So I now know r is equal to negative 2. G sub 1 is my first term, which is 1. So I'm going to go ahead and plug all that into the explicit formula. G sub n equals 1 parentheses negative 2 parentheses closed and minus 1. And I want to find the 15th term, so he's going to go in the n spot. So it's g sub 15 equals 1 parentheses negative 2, 15 minus 1. And when I plug all that into my calculator, I get 16,384. All right, let's do one more. Determine whether each sequence is arithmetic or geometric, then use the appropriate recursive formula to determine the unknown terms in the sequence. Remember, recursive formula just means you're going to use the previous term to get that next term. All right, so we've got 4, 8, 16, 32. You can see these numbers are going up very quickly. So I'm going to go ahead and guess that it's geometric, and I'm going to check it by doing 8 divided by 4, and I get 2. 16 divided by 8, I also get 2. And 32 divided by 16, I also get 2. So this is my common ratio. R is equal to 2. And to use the recursive formula, all I'm going to do is multiply that previous term by 2. And 32 times 2 is 64. And that would be our answer. And then down here, we've got 16, 30, 44, 58. See how these terms are going up fairly slowly. So I'm going to guess it's arithmetic, and I'm going to check to make sure by doing the subtraction method. So 30 minus 16, that gives me 14. 44 minus 30, that also gives me 14. 58 minus 44, and guess what? There's a 14 again. All right, so I got 14 every single time. He is known as my common difference. So I know this is arithmetic. And then to get to that next term, I'm going to add. So 58 plus 14, that leaves me with 72, which is my fifth term in that sequence. Write the explicit formula for the arithmetic sequence a sub n equals 7 minus 3 times n minus 1. We're going to write that in function form. Okay, so our very first step is going to be to replace this a sub n with function notation. So let's go ahead and write f of n equals 7 minus 3 times n minus 1. That's our very first step. Now what we're going to do is we're going to distribute this negative 3 into the parentheses. So we're going to use the distributive property and multiply the front term and the back term by negative 3. So I would still have f of n on the left-hand side. The 7, nothing's happening to him, so we can just write him down on the bottom. So we get 7, and then negative 3 times n. So that's negative 3 times n, which is going to be negative 3n. And then I have negative 3 times a negative 1. So let's think about that. Negative 3 times negative 1. We have two negative signs. That's going to now be positive. And 3 times 1 is just 3. So this is going to be a positive 3. All right, now that we get to this step, we need to use our combine like terms. This guy has an n, this term has an n, so he does not get combined with anything. And then we've got the 7 and the positive 3. Remember, they're on the exact same side of the equal sign, so we just combine like terms. We do exactly like we see. So on the left-hand side, we have f of n equals, and then over here I have a positive 7 and a positive 3. If I add 7 to 3, I'm going to get 10. So my function over here is now going to be negative 3n plus 10. And this would be rewriting this explicit formula into function notation. Describe the pattern shown below. So let's first look at this group of circles. We have 1, 2, 3, 4 circles going down, and then we have 1, 2, 3, 4, 5, 6 circles going this way. So I don't know if you guys know this real quick trick. If you take 4 and you multiply it by 6, that'll give you the exact amount of circles that are in this first term. So 4 times 6 is 24. All right, now let's look at the second grouping. We have 1, 2 going down, 1, 2, 3, 4, 5, 6 going across. So if I do 2 times 6, that gives me 12. That lets me know that there's 12 circles in that grouping. And then over here, we have 1, 2, 3, 4, 5, 6 again. So now my third term in this sequence is 6. And then in the very last one, I have 1, 2, 3. So I know that my fourth term is 3. And what we need to do is describe the pattern shown. So we're going from 24 down to 12, down to 6, down to 3. So think about it. If we subtract 24 and 12, I get a difference of 12. But yet, if I do the difference over here, I get 6. So I know it's not going to be going down by the same amount by subtracting. I need to look at maybe another relationship between these numbers. And I can tell that 24 and 12, if I divide by 2 here, then I do get 12. And if I divide by 2 again, I get 6. And if I divide by 2 again, I get 3. So it's definitely dividing by 2. We just need to describe that. So how I would describe it is that the amount of circles are decreasing by half. If you wanted to think about if this would be arithmetic or geometric, remember what we talked about is that we've got dividing by 2. And dividing by 2 is the exact same thing as multiplying by 1/2. So if we multiply by 1/2, that would be a geometric sequence. So this would be geometric, and our r would be 1/2. But this sequence was just, or this problem was just asking us to describe the pattern shown, and the describing would just be the amount of circles are decreasing by 1/2. Or you could also say there are half remaining with each term. What is the next term in the sequence? So here I'm not telling you what sequence it is. You have to look at our sequence here and see if you can figure it out. Well, look at our numerator. Our numerator is staying at 1 the whole entire time, and our denominator is going from 2 to 6 to 18 to 54. So you can tell that these numbers are not close together at all. So let's see if we're multiplying by something. So to check to see that, you could always do 6 divided by 2, 18 divided by 6, and 54 divided by 18, and see if we get the same number. Well, 6 divided by 2 is 3, 18 divided by 6 is also 3, and 54 divided by 18 is also 3. So the fact that we got the same number for all three of these, then we know that our common difference, or sorry, not common difference, our common ratio is going to be 3. So our R is going to equal possibly a 3, but where was he located? He was located in the denominator, and my numerator is staying 1 the whole entire time. So if I need to multiply the denominator by 3 and the numerator needs to stay at 1, then my R is actually going to be 1 over 3. So what is the next term in this sequence? Well, I would go to 1 over 54, and I would just multiply it by 1 over 3. And 1 over 54 times 1 over 3 is 1 over 162. So the answer to this question would be 162. All right, write the explicit function from the graph. All right, to be able to write the explicit function, we got to think about what is all involved in the explicit function. Remember our formula, a sub n equals a sub 1 plus d times n minus 1. And if all they want is just the explicit function, we don't have to worry about writing it in function notation. So the first thing we need to do is find that first term. So when we think about it, here are our term numbers down here. We want the very first one. So we need to go over to the very first one, which is 1, and look at that dot right there. Well, he's not completely at 4, and he's definitely not completely at 0. So we need to pay attention to our y-axis. What is it going up by? What is my interval? Well, the y-interval for my y-axis is 4. So if my dot is somewhere in the middle of it, it's actually perfectly in the middle, you would have to think, well, what number would go in the middle of 0 and 4? And that answer is 2. So 2 is going to go right there. So our very first term is actually 2. So from that, I got a sub 1 equals 2. So I'm going to go ahead and I'm going to put 2 into my formula. So I've got 2 right there. Make it a little bit darker, sorry. And I've got a sub n equals 2. Now I just need to figure out what my difference is between the very next term. So let's go back over to our table. I've got our second term is 6. So if I were to write out that point, it would be our second term is 6. And let's go ahead and do the third term as well. Our third term in between 8 and 12 would be 10. So our third term is 10. Look at what's happening to my y values. My first term is 2, my second term is 6, and my third term is 10. So if you were to write that sequence out, 2, 6, 10, what would our common difference be? Well, if you can't tell, you could always do the second minus the first term, third minus second, but hopefully you guys would be able to see that the difference between these guys is 4. So when I go to put d equals 4 into the problem, he just goes right into that spot right there. So I would go ahead and put 4 parentheses n minus 1, and that would be the answer if all they wanted was an explicit form. But you know me, I'm going to go ahead and keep practicing writing it in function notation. So let's go ahead and extend this question even further, and let's go ahead and try to write it in function notation. So remember, the very first step to do if we're going to write it in function notation is replace a sub n with f of n. So that's the very first step. So I have f of n equals 2 plus 4 parentheses n minus 1. Now our next step, or sorry, the really first step, that was the first step. Our next one would be to go ahead and distribute this positive 4 into the parentheses. Well, there's going to be a first term and a second term. All right, so we have f of n equals, nothing's happening to the 2, he's just staying right there, and then we have plus 4 times n. So that's going to be a positive 4n, and then we have a plus 4 times a negative 1. So notice our signs are different. We have a positive term and a negative term, and when you multiply those, it's going to end up being a negative answer. So we have 4 times 1, or sorry, positive 4 times a negative 1 is going to be a negative 4. All right, now our last thing we need to do is combine our like terms. We've got a 2 here and a negative 4 there. And if we think about it, 2 minus 4 leaves me with a negative 2. So both of these terms together equal a negative 2. So let's go ahead and write our final answer. F of n equals positive 4n minus 2. And this would have been the answer if it asked it in function notation. But it didn't ask it in function notation, it just wanted to write as the explicit function, and that would be this answer here. Alright guys, thanks so much for watching the video. I hope this really helps you study for your test, and I hope we all do fantastic on it. Alright, see you in class soon.